Addressing modes of 8086. We have immediate addressing mode, register, direct, indirect. We have already discussed these four addressing modes in 8085 microprocessor. Now these six coming from based index to based index relative addressing mode, based index, based relative, index relative, and based index relative. These six are the new addressing modes of 8086. Coming to the first one, that is immediate addressing mode, like MOV AL34 or MOV AX234H. That means the immediate data 34 will be moved into the AL immediately, or 1234 is moved to AX immediately. That means this 34 immediate data is moved into the AL register. AL is of 8-bit, and AX, which contains AH and AL, that is of 16-bit, will be getting the data which is 16-bit data, immediate data, that is 1234H. So this 34 is moved to AL, that is of 8-bit register. 34 is hexadecimal. 34 hexadecimal, that means 8-bit binary data. 1234 16-bit data, that is moved to AX. Register addressing mode, that means we are moving the data from the register to register. Source is also a register, destination is also a register. 8-bit or 16-bit data we can use to have the register addressing. If we talk about move AL comma BL, that means BL will have the data which will be moved to AL. That means destination is AL and BL will be treated as a source register. Similarly, a BX having 1234 data will be moving its data into the AX by using this particular move command. Direct addressing mode, that means we are giving the memory location of the operand where the data is available, the operand is available, we are providing the location of that particular data is direct addressing mode. The example is move AL comma 400 or move AX comma 4004. If we talk about move AL comma 4000H, that means 4000H memory location will have the operand that will be moved to the AL register. And if we talk about move AX comma 4000H, that will be in square bracket that shows the memory location 4000H. That means 4000 and 4001H will be having the operand which will be moved into the AL and AH registers separately, because AX that will be having AH and AL will individually contain an 8-bit of data. So this 22 will be moved in AL, and this 33 from the next memory location 4001H will be moved into AH. Next is indirect addressing mode. That means the operand will be stored in a memory location whose location or address will be given by the register. That will be indirect. That means BX will be having the address or memory location of the operands. So BX contains 4000. That means the data or operand will be available in the memory location 400 and 4001. So the 22, that is the data available at 4000 location, will be moved to AL, and the next memory location data, that is 33, will be moved into AH. Next is based addressing mode. This addressing mode will be we use bx, that is base register, or base pointer bp registers as a source registers. The address of the operands are available in these source registers. So bx or bp will have the data. That data is nothing but the memory location of the operands which are going to be moved into the AX register. So 4000 and 4000H, 1H will be the memory locations of the operands which are going to be moved in AL and AX registers one by one. So 22 will be moved into AL and 33 will be moved into AH. This 4000 will be the memory location for the address. Indexed addressing mode, that means the same which is based addressing mode, but the thing is that instead of BX and BP we'll use SI and DI registers to get the memory location of the operand. So this SI and DI will be giving you the memory location of the operands available in the memory location, whose address will be given by this SI and DI. Previously in based addressing mode we'll be getting the address of these operands from the BX or BP, base pointer and base indexed registers, but in indexed addressing mode we'll be getting the address of the operands by SI and DI, that is source indexed register and destination indexed registers. So this 22 will be moved into AL and 33 will be moved to AX, and this SI and DI will be having the data, will be having the address of the memory location in which operand is available. Based indexed addressing mode, that means BX in a base register plus source index or destination index will cumulatively provide you the address, base address of the memory location in which the operand is available, which will be moved to the AX register. So move AX comma BX SI, that means BX plus SI will give you the address of the memory location, and that 22, that means data which is available at 4050, 4000 is base BX and SI is 0050. So cumulatively it is 4050. 4050 and 4051 will be having the data, and 22 will be moved to AL and 33 will be moved to AH. Next is based relative addressing mode. Based relative addressing mode, we'll be having an offset or displacement in 8-bit or 16-bit, which will be given by 1 2 or 1 2 3 4, for example, in this case. So based relative addressing mode, that means we'll be having an offset which will be added to this base index value. So BX will be having the value that is 4000 in this case, and displacement or offset, 8-bit displacement is 1 2, 16-bit displacement is 1 2 3 4. For example, I have taken this 16-bit displacement or offset. Adding these two terms will give us the memory location, that is 5234. This is the final indexed address where the operand is available. So this 5234, that is this memory location, the data is available, that is 1 2 will be moved to AL, and this 34, the next memory location, the data will be moved to AH. Next is indexed relative addressing mode. Indexed relative is similar to based relative addressing mode, but in base relative we'll have the base index register, and in this indexed relative we'll be having the address will be given by the source index or destination index register. So this SI plus this offset displacement, adding these two terms will give us the data, that is the final index address of the operand 5234, and the next is 5235. So 5234 data will be moved to AL, and 34, that is next location data, is moved to AH. Sorry. Next is based index relative addressing mode. To get the address of the memory location where the data, the operands are available, we will add these two terms, that is base index register plus source index register plus the offset, either 16-bit or 8-bit. So we add bx value, that is 1000, plus the source index value, that is 3000, plus the offset, that is 1234, to get the final index address, that is 5234, which will be available in a memory location where the data is available, where the operands are available. So this 1 2, that will be moved to AL, and 34, that is next memory location data, will be moved to AH.